In the name of God, the most gracious, the most merciful, peace be upon you and God's blessings. We will start our discussion about the third case of Mohr's circle of inertia, where Ix is bigger than Iy and Ixy is negative. What are the shapes that fulfill these two requirements? The first case is the case of unequal angle, with the longer leg at the left and the shorter leg at the base, Ix and Iy, Ix and the product of inertia Ixy is about its CG. The second case is the case of right angle triangle case 1, where the height h is bigger than the base b. We recall that Ix as a CG is b h cubed divided by 36. Iy as a CG is equal to h multiplied by b cubed divided by 36. And Ixy as a CG is minus b squared by h squared divided by 72. For that case, if we apply the relation tan to theta equals minus Ixy divided by Ix minus Iy over 2, we have negative multiplied by negative, which is Ixy, divided by Ix minus Iy over 2, which is positive. The final signal is positive. The angle 2 theta b will be in the first quarter and third quarter. In the next slide, we have two expressions for the inertia about inclined axes. The first expression is Ix dash equals Ix plus Iy over 2 plus Ix minus Iy over 2 multiplied by cosine 2 theta minus Ixy sine 2 theta. While the second expression is Iy dash equals Ix plus Iy over 2 minus Ix minus Iy over 2 multiplied by cosine 2 theta plus Ixy multiplied by sine 2 theta. When will be Ix dash maximum? It will be maximum if cosine 2 theta b1 is positive and sine 2 theta b1 is also positive. For the second and third terms in Ix dash equation to be positive. Since we have positive plus positive multiplied by positive minus negative multiplied by positive, this means that 2 theta b1 is in the first quarter, where sine and cosine both is positive. Consider 2 theta b1 as the angle from the x-axis to the u-axis in Mohr's circle of inertia in the anti-clockwise direction. In the normal view, where axes x and y are orthogonal, we can write theta b1 plus theta b2 equals 90 degrees, while in Mohr's circle of inertia, 2 theta b1 plus 2 theta b2 equals 180 degrees. The moment of inertia Ix dash will be minimal when cosine 2 theta b2 is negative and sine 2 theta b2 is negative. Since we have plus positive multiplied by negative minus negative multiplied by negative. This means that 2 theta b2 is in the third quarter. Consider 2 theta b2 is the angle from the x-axis to the b-axis in Mohr's circle of inertia in the clockwise direction. In the normal view, where axes x and y are orthogonal, we can write theta b1 plus theta b2 equals 90 degrees, while in Mohr's circle of inertia, 2 theta b1 plus 2 theta b2 equals 180. We have not talked much about Iy dash expression. When the angle 2 theta equals 0, we get Iy dash equals Iy. When we will be the Iy dash maximum, it will be maximum if cosine 2 theta b2 is negative and sine 2 theta b2 is also negative. Since we have positive minus positive by negative plus negative by negative. This means that 2 theta B2 is in the third quarter. Consider 2 theta B2 is the angle from y-axis to the u-axis in Mohr's circle of inertia in the clockwise direction. When will be Iy dash minimal? It will be minimal if cosine 2 theta B1 is positive and sine 2 theta B1 is also positive, since we have positive minus positive by positive plus negative multiplied by positive. This means that 2 theta B1 is in the first quarter. Consider 2 theta B1 is the angle from the y-axis to the v-axis in the anti-clockwise direction. In the next slide, a discussion of Mohr's circle of inertia reveals that the circle gives the u and v directions in the horizontal direction while the x-axis is tilted. For case 3, based on our previous discussion, the angle between x-axis and v-axis is angle 2 theta B2 in the clockwise direction in the third quarter. The angle between the x-axis and the u-axis is angle 2 theta B1 in the anti-clockwise direction the first quarter. We draw Mohr's circle of inertia, which enables us to determine the maximum, the I maximum and I minimum after we get the radius of Mohr's circle. In the normal view, we have the x-axis in the horizontal position, so we need to rotate the x-axis and all the relevant axes u, v and y axes by an angle of 2 theta B1 in the anti-clockwise direction in Mohr's circle of inertia. We can find that the u direction in the normal view is above the x-axis by an angle of theta B1, while the v direction in the normal view is below the x-axis by an angle theta B2. The axis IXY will rotate as well, and we will discuss that in the last slide. These are the step-by-step procedures to construct Mohr's circle of inertia. Number 1, draw a horizontal axis representing Ix, Iy, I max and I minimum. Number 2, draw a vertical axis representing Ixy in the upward position, where Ixy is positive. Number 3, locate the point which has a coordinate of Ix, minus Ixy, since we are talking about case number 3 of Mohr's circle. Point A is drawn on the right side, and with Ixy downward, it will be on the lower right side. Number 4, locate point B, where a coordinate of Iy, plus Ixy. The point B is drawn at the right side, and with Ixy upward, it will be in the upper left side. Number 5, join the 2 points A and B and cut the x-axis in point O, which is the center of Mohr's circle of inertia. Number 6, draw the circle with the radius equals to OA equals OB. The coordinate of point O is Ix plus Iy over 2, 0. Since we have Ix is bigger than Iy, the radius of the circle is equal to the square root of Ix minus Iy divided by 2 squared plus Ixy squared. Point E is the maximum value of Ix, and it equals Ix plus Iy over 2 plus R. Point C is the minimum value of Ix. It equals Ix plus Iy over 2 minus R. We can find that the line OA represents the x-axis in Mohr's circle, while line OB is the y-axis in Mohr's circle. The next slide, we create a mirror point A dash with a coordinate of Ix, plus Ixy. and also create another mirror point B dash with a coordinate of iy, minus ixy. Why do we need that points A dash and B dash? Joining OA dash will show the U direction when the x-axis is in the horizontal direction. Imagine that we rotate axis OA in the anti-clockwise direction by 2 theta B1. Joining OB dash will show the B direction when the x-axis is in the horizontal direction. The angle 2 theta B2 is the central angle shown between axis X and axis B. In the next slide, we want to get the direction of the U-axis in the normal view and its angle. Join C with point O dash, with point A dash. The enclosed angle is theta B1, which is half of the value of the central angle 2 theta B1. Join C with point B dash. The enclosed angle is theta B2, which is half of the value of the central angle 2 theta B2. Due to the rotation of axis X by an angle 2 theta B1, the IXY will also rotate. Consider the U-axis as your datum and modify the IXY axis by making it parallel and to the left of a perpendicular line to U at point O and offset by a distance of IX plus IY over 2. Now we have the x-axis as a horizontal axis. Check for theta equals 0 and find point E with a coordinate of IX minus IXY. The OE distance is the radius R. Check for theta equals 2 theta equals 180. We find point C with a coordinate of IY minus IXY. The OB distance is the radius R. The distance IY is measured from the IXY new datum, while the minus IXY distance is negative below the U direction. Thanks a lot and see you. Goodbye.